Welcome to clickmyproject.com. Let's discuss about the product. Our product is Demosaicking of color filter array patterns using Quaternion Fourier transform and low-pass filter. In this paper, we present a novel color demosaicking algorithm to voting based edge directional and direction method and a directional weighted interpolation method. By introducing the voting strategy, the interpolation direction of the center missing color component can be determined accurately. Along the determined interpolation direction, the center missing color component is interpolated using the gradient weighted interpolation method by exploring the intra-channel gradient correction and the neighboring pixels. As compared with the latest demosaicking algorithms, experiments show that the proposed algorithm provides superior performance in terms of both objective and subjective image quality. For cost reasons, when the currently available digital still color cameras captures a color image, for each pixel only one part of color information of the 3 color channels is captured based on a single charge coupled device sensor. Typically, only one 8-bit number that measures the amount of red, green or blue is captured in the pixel. The sensor is covered with a color filter array, that is CFA, which causes each pixel in the camera to capture only one color channel. This is because only one color element is available in each pixel, and the 2 missing colors must be estimated from the adjacency pixels. This process is called interpolation or CFA demosaicking. The color reproduction quality depends on the color filter array templates and the demosaicking algorithms that are employed. Based on the Bayer pattern, various demosaicking algorithms have been proposed in the past few decades. These methods were proposed to obtain a full color image by utilizing the color difference between the green and the red or blue planes in spatial domain or frequency domain. The advantages of these methods is that it is the efficiency in a smooth region. However, these methods suffer from more or less artifacts on the reconstructed irregular edge and texture details if the interpolation direction is not estimated correctly. So, the flow diagram gives an overview of our product. Initially, we have taken a color image which is to be demosaicking. So, as we already discussed, the CFA concludes the overall process of demosaicking. That means the CFA is not a separate process; it concludes the overall some subdivisional functions in the process. So, initially, taken image is taken for Bayer encode, and the Bayer encoded image is applied to cross filter, and then the cross filter array is applied. After that, QFT, that is Quaternion Fourier transform, is applied to the process. So by the QFT after image, that image is finally obtained, which is called a demosaicking image. Let's see the demonstration of our product. As we already discussed, our product is based on MATLAB programming language. That means our product is based on MATLAB programming. We have program in main.m. So you can see in the work directory, this is a MATLAB main window. So we have used the MATLAB 13 years as a lesson for the development of this product. So these yellow color files are called a mat file, that is a matrix file which contains the values. So regarding to selected image, the details will be visible here. So main.m, you can see the similar name with different formats, that is .m and .figure. So this is the programming file and this is the graphic user interface. While I am running the program file main.m, it will recall that main.figure as a frame or for button process. So here I am selecting the main.m and I am going to run the process. So the main frame will open. So this is the main frame of our process. Here these are called the access and these are called the push buttons. Every push button has its corresponding code in the back end of this product. That means as a MATLAB programming. So initially, for example, if I am pressing the select image process, means it will redirect the database folder and we have to select an image that will be visible. So I have processing select image. Inside the data, I am going to select any image as input. For example, I am selecting the image. So the selected image will be visible here. So for crop, so for what I am doing crop reason is here, because for every demosaicing process it will not be visible for applying full images. So if you are selecting a particular region by cropping, means that will show what are the interpixel values for visible. So see, I have selected a little bit and I am cropping that particular region. So you can see these changes in the image. You can zoom and see the changes. So I am going to process this image. I am applying Bayer encode. This is the Bayer encode process, and decode I have to do. So during this encode decode process and noises are removing, and then applying filtering. So during this component filters, then you can see the daughter pixels. This process is called the process to be removed by the cross filters. So I am applying cross filters. So during this cross filter, that we can identify the components. That means if we know every channels, that means RGB channels, there are 3 channels, red, green and blue. In every channels we can see what are the components and what are the components to be filtered and what are the components to be replaced. So those components are identified during this cross filter. And then for demosaicing we are applying LPS filter. So during this filter we are obtaining final filtered image. So and then we are applying QFT spectrum. That means in that we are processing Quaternion Fourier transform. So this overall process is called the color filter array. So in color filter array, as we already discussed, most of the demosaicing process is based on encode, Bayer encode, and our CFA also based on this Bayer encode. Here I am doing QFT spectrum. So you can see the values, PSNR values and everything will be here. So the final spectrum of our image, so that is shown here. So the performance of the proposed system will be visible here while pressing the process. So this is the comparison chart with PSNR and MSE value, that is mean square error. Thank you.